Hello all, I am Dr. Pravas. In today's class, we will discuss about the ALR parsing table, ALR parsing algorithm, or we can say ALR parser, or we can say ALR parser, or we can say ALR parser. So, what is the meaning of ALR parser? ALR means what? What is the meaning of ALR? So here, the L means left to right scan, left to right scanning, left to right scanning. So what is the meaning of R? What is the meaning of R? We can say here, we can write here. R means rightmost derivation in reverse order. Rightmost derivation, rightmost derivation in reverse order. In reverse order. Okay. So LR parsing algorithm, or we can say LR parser. What is the meaning of L? L means left to right scanning. We have already discussed about what is the meaning of left to right scanning in the previous classes. Left to right scanning means suppose a string is like suppose A, B. Here we'll scan from left. Left means here A. Left to right scanning means A to B. This is the leftmost element, then the next. So I'll first scan means not I, actually the LR parser will scan first A then B. This is called left to right scanning. Rightmost derivation we have also discussed in the some previous classes. Just see what is the meaning of leftmost derivation, what is the meaning of rightmost derivation. Okay. So that means okay. Hope all of you clear about the LR parser. Okay. Now we'll see the steps or the algorithm of LR parser. How to construct the LR parser. Okay. See. Let S be the state. Let S be the state of on the top of the stack. Let S be the state on the top of the stack, and this A. And this A be the look ahead symbol. A be the look ahead symbol. Means here two terms are there. Two terms are one is S and one is A. This S means this is the state on the top of the stack, and this A means this is called as the look ahead symbol. Okay. So this is the first step. First step means initially push initial state of the DFA. Initially push initial state of the DFA into the top of the stack. First we will push initial state on the top of the stack. Then the parser takes a decision regarding shift or reduce action. Then the parser will decide either it will follow the shift action or reduce action based on the initial state of the DFA. Okay. Don't worry about this theory. When we'll try to means also we'll design one question or one example. Means how LR parsing means algorithm generally pre-process the means input string. Okay, don't worry about this theory. So the next, then what is the meaning of shift action? Okay, then the parser will take the decision regarding about the shift and reduce action as follows. Okay, so the first action is S to A shift J. Means suppose shift 3 or shift 4 like this. Okay, this is the shift. S3 means this is called as the shift action with its number is 3. S4 means this is called shift action, its number is 4. Okay, suppose shift J in LR parsing table. In if shift J, or we can write shift J, or we can write SA. We can write also like this. This shift J we can write like this. SA. Shift J in LR parsing table means what? Shift this A. Shift A means this terminal. Shift A means this terminal into the stack, and then shift this number. Shift the number like J, or the number like 3 or 4 into top of the stack. First shift this terminal means first we'll shift A, then we'll shift its number like J, or we can say if it is S3, example is like S3, then we'll push like 3 on into the top of the stack. Okay, means first we'll shift the terminal, then we'll shift its number. Okay, then this is called as the first action is called as shift action. Then the second action is called as reduce action. If the action S to A, if the action S to A is reduced, if the action A to S to A is reduced, what happens? See here. Here, if the action S to A is reduced like one, one prediction here, A to beta. Let one prediction is like A to beta. Then pop 2 times. Then pop 2 times. This is very, very important. Then pop 2 times of length beta. Then pop 2 times of length this beta, means in the RHS part. Then pop 2 times of length beta, or we can say 2 times of beta or 2 times of RHS part. 2 times of RHS part we can say. Length beta symbols from the stack. Then from the stack. Then replaced by A. Then replaced by A means in the LHS part. On top of the stack. On top of the stack. Then push go to. Then push go this S and this A. This S and A in top of the stack. In top of the stack. Don't worry about this theory. We'll also do one example, suitable example. With the help of one example, we'll clear about the shift action, what is the meaning of reduce action. Okay. Then the third action. Third action is the accept action. Third action is called the accept action. Accept action. So what is the meaning of accept action? If the action S to A, if the action S to A is accept, then the input string is valid and parsing is successful. Means for every accept action, the string is always valid and the parsing is always successful. What is the fourth action? An action S to A is blank. If the action S to A is blank, then there is a syntax. Error. So generally there are 4 actions. First one is a shift action. Second one is called a reduce action. Third action is called as accept action. Fourth action is called as error action. Okay. Based on these 4 actions, we'll do means input string is valid or not. Input string is valid or not using LR parsing algorithm. Okay. So now we'll see one suitable example. What is the meaning means we'll try to understand these 4 actions and the LR parsing algorithm using this given example. Okay. So note, one important note here, the time complexity. What is the time complexity of LR parsing algorithm? The time complexity of this algorithm means LR parsing algorithm is always order of n. Here, what is the meaning of n? Here, n is the length of the input string. Here, n is the length of the input string. Okay. So now we'll see the example. See. Here's the example. How many shift and reduce actions? How many shift and reduce actions are taken by the LR parser? For the following. Here input string is AB. Here the input string is AB. For this input string, one context-free grammar is given: S to AB, A to A, and B to B. This context-free grammar, CFG grammar is given. This is the given input string. Now we'll check how many shift and reduce actions and this input string is valid or invalid. Okay, this table is called as LR parsing table. LR parsing table. This table is called as LR parsing table. Right? This table is called as LR parsing table. See, in the left side, I0, I1, I2, I3, I4, I5, these are called as the number of states. These are called as the states of DFA. These are called as the states of DFA, right? See, what is the meaning of A, B, and dollar? Up to A, B, and dollar, it is called action. These states are called as, this is called as action. Means A to dollar, A to dollar, it's called as action. And these steps are called as SAB, it is called as go to. It is called as go to. This is called as go to. Okay. So go to means SAB. These are called as go to, and actions means AB dollar, and these are called as in the left side it is called as I0, I1, I2, I3, I4, I5. It's called as the number of states. This is called the number of states. Okay. Okay. Now we'll check this AB. Now we'll check this AB is valid or invalid. Okay. So how to see it? Just a minute. Okay. Now we'll do stack input buffer, then action, Okay. So remember, in the stack always contain, this is dollar and 0. 0 means this is called initial state. This 0 means this is called initial state. Stack always contains means initially contains dollar and initial state of this DFA. Initial state of the DFA means this is called 0. What is the meaning of input buffer? Here input buffer is AB and dollar. Okay. This is very simple. Means initially the stack contains dollar and 0, and the input buffer contains the input string AB and dollar. This is the initial phase. Okay. Now we'll see how to process here. This is called 0. What is the top of the stack? The top of the stack always contains here 0. The top of stack contains generally 0. Here 0. What is the first element of the input string? The first element of input string is here A. So 0 to A. Just check the table. 0 to A is which action? 0 to A is S3. 0 to A is S3. S3 means this is called shift action. S3 means here this S is called as shift action and R means reduced action. Number 2. Here shift action means S3 is number 3. S5 means shift action number 5. R2 means reduced action number 2. R1 means reduced action number 1. R3 means reduced action number 3. Okay. So first action is shift. Now we'll shift on top of the stack. But A, see, this is the dollar. This is 0. Now we'll push or shift this A on top of the stack like A. Okay. Then we'll push the number of shift action. What is the number of shift action? Here the number of shift action is 3. So now we'll push 3. So then the remaining element of the input string is B dollar. Right. Now we'll see 3 to B. Here top of the stack is 3. Then what is the input buffer contains the first, then the next element of, or the first element of input buffer is B. So 3 to B. Just like 3 to B is what? 3 to B is R2. 3 to B is R2. 3 to B is R2. R2 means this is called a reduced action. So now we'll check what is the meaning of R2. See, just see here. Just make the number. This is 1, this is 2, this is 3. R2 means here, R2 means, see, R2 means this is called reduced action. R2 means this is called A to A. This is the second number. R2 means this is called a reduced action. And reduce means we will reduce this second one, means A to A. A to A. Okay. See, R2 means A to A. So how many elements will reduce from the stack? Will 2 times of RHS part. 2 times of RHS part. So means 2. The RHS part contains only one element, means A. So 2 into 1 equals to 2. The RHS part contains only one element. So 2 into 1 equals to 2. Okay. 2 times of RHS part. 2 times of RHS or elements in the RHS part. Okay. The RHS part contains one element. So that's why we will eliminate, we will remove two elements from the stack. So see, so we'll remove these two elements from the stack. So this $0. Okay. Now we'll replace this A on these two elements, means A and C. Okay. So this is A. Now it is $P. Now it is $P. See, 0 to A, just check 0 to A means what? Just check the table. See, 0 to A. This 0 means state. 0 to A. 0 to A means what? 2. So simply write here 2. Okay. Now we'll see. Top of the stack is 2, and here input buffer contains B. So 2 to B. Now we'll check 2 to B. 2 to B equals to what? See here. 2 to B. 2 to B is S5. 2 to B is S5. Simply write S5. S5. S5 means we'll shift or we'll push this B and its number 5. So $0 A 2, then B. Now we'll push B and its shift number is 5 here. 5, then $. So now top of the stack is 5. Then input buffer contains $. $5. Just check what is the meaning of $5. $5 to $. $5 to $. Is R3. $5 to $. Is R3. This is called reduced action. R3 means this is called a reduced action. Now we'll check what is the meaning of R3 here? Reduce 3. Reduce 3 means the third production. The third production is B to B. B to B. The third production is here B to B. Okay. Now see, third production is B to B. Now how many elements will remove from top of the stack? 2 times. The RHS part contains here only one element. So 2 into 1. 2 into 1 equals to 2. 2 into 1 equals to 2. Means we will remove 2 elements from the stack. So how many elements? 2 elements from the stack. Okay. So this is dollar, this is 0, this is A, this is 2. We'll remove 2 elements and we'll replace by these 2 elements are replaced by this B, means LHS part. This is B. Then dollar. Now we'll check 2 to B. 2 to B is go to action. 2 to B is which action? Go to action. See, 2 to B. 2 to B is 4. 2 to B is 4. So now I'll write here 4. Okay. Now we'll see 4 to dollar. 4 to dollar. 4 to dollar is what? See, 4 to dollar is R1 action. 4 to dollar is R1. R1 means what? Just check the grammar. R1 means S to AB. R1 means S to AB. So see, R1 means S to AB. Okay. So how many elements I will remove from the top of the stack? See, here the RHS part contains 2 elements, means 2 into 2. 2 elements means twice of RHS part. 2 into 2 equals to 4 elements. So I will remove 4 elements from top of the stack. 1, 2, 3, 4. Okay. See here. This is dollar. This is 0. Then these 4 elements are replaced by this S. Then this is dollar. See here. Now we'll perform the go to action. Now we'll perform the go to action. What is the meaning of 0 to S? Here 0 to S. 0 to S is 1. This is 1. What is the 1 to dollar? We can see 1 to dollar. 1 to dollar is accept action. 1 to dollar is accept. Okay. So the input string is valid. So the here the input string is valid, means this AV, this input string is valid, means accepted by the ALR parser. So question is, so see here, this is the overall. So here the question is how many shift and reduce actions are taken by the ALR parser. Now we'll count how many total actions. How many total actions now we'll count? Total actions. See, this is 1, 2, 3, 4, 5, 6. The total actions are 6. So how many shift action? See here, how many? 1, 2, 2 with the shift action. So how many reduce action? How many reduce action? 1, 2, this is the 3. So 3 reduce action, 2 with the shift action, and the total actions are 6. Okay. So in this way, we can do the ALR parsing algorithm. Okay. In the next class, we'll also continue the ALR parsing algorithm with the help of one more example. Okay. Thanks for watching.